So hello everyone. So my name is Luis Peluso. I'm working in AI electronics as a lead software developer for more than a year now. And then we're trying to help the team to get like more efficient development and reuse as much as we can from years of development done so far, and try to get like a pipeline of development. And then one of the approaches is using TestStand for production environments. More specific, like using turnkey solutions for the production. So very easy for operators to use, very intuitive for our maintenance then as well. So I'm going to show a few ideas that got us here. So is the major part is the user interface module that we couple to TestStand, and our design thinking and how we come up to this point. Then yeah, just get my presenter view. So this is the part of the agenda. So we're going to start with a little bit of what the legacy UI UX I'm trying to reuse as much as we can. Some stuff we're developing LabVIEW, some stuff we're developing other languages we are still incorporating and translating to LabVIEW. How modularization works with TestStand. Very brief introduction to TestStand modules and TestStand steps, just for those who didn't work with TestStand. So the architecture design, the idea behind all the implementation, the real implementation, how we are going to use, and a little bit of demonstration. The demonstration is supposed to be simple, it's a simple usage. The real case is much more complex, but then we give the idea. Yep. So a little bit what we are doing at EI. So we do fire and gas detection sensors and IoT as well. So the sensors now, they are more often interconnected and connected to the cloud. So tests are getting more robust, more RF tests, more smaller footprint for electronics, so harder for tests, and much more functions. So it's keep evolving all the time. EI Electronics, they are the lead in fire and gas, by the way, in Europe. So they have different markets, different requirements to cover. So a lot of products to be tested. And here's basically the idea. So how they work as a lean manufacturing. So the base of lean manufacturing, they try to make the process in a smaller footprint, but covering much more of the features. And they have like since ICT, we do SMT in-house, then we go for ICT, the in-circuit testing, and then we go for individual stations, some manual work, and then some automated and semi-automated tests that we call functional tests. In this case, I'm going to use a particular tester called mode function tester that we have here. It's like 5 stations, so it just has 4 products in parallel, one load and unload station parallel too. That's basically look like a cell in EI. So this picture is from Cell Controls, a key partner from us here in Ireland. This is one of the cells we have, and then that's the more or less idea. A little bit of manual work, a little bit of automated robots, and then automated testers like the big pass on the screen there. And until the end, they get the product in a package sent to the customer. So that's more the context, how we work. And now I start jumping on the design thinking of this implementation. So the idea is a lot of legacy, a lot of development was done before. And when I started with the team, the idea is right, okay, we need to start organize our development. Let's not, discard all the stuff that was developed. Let's try to use as much user experience, at least for operators and technicians as possible. So some ideas just come in mind. Let's treat the other people's house as our house. What goes around comes around. So we keep the respect to the legacy, and it's very useful, by the way. It helps us a lot to deploy and deliver machines because operators and the trainers and technicians are used to. So we keep trying to keep the same style. So a little bit of the environment I found and how scattered it was in the beginning. We had development systems like in C#, C++, CVI, different types of LabVIEW. So different generations of LabVIEW, LabVIEW NXG was done basically by engineering validation. They now actually are going to start to leverage everything to LabVIEW, CG. Then other languages as well, Python, PLC ladder, other types of DLLs, .NET calls, and much more. This is only the software side. The hardware as well, there was no much commonality. Like different platforms for operational systems, different hardware architectures that was a little bit overkill, or they were lacking of a little bit more organization, but PXIs connect to PCs that were connected to USB DACs as well. So we are trying to standardize with PXIs and compact DACs now, and some PCs as well, different machines, those that don't need so many IOs, but just get some standardization on that side too, helps a lot in software. I found Raspberry Pi, some ASIC systems just dedicated for the specific tester, PLC running safe systems and running testers as well, HMIs, so different stories. The idea here now is try to bring as much of the modules we can, or redevelop them in LabVIEW, or incorporate in some LabVIEW templates we have, or TestStand in the case I'm showing here. Yep. And that's the scenario we found. Actually, exactly kind of stud case from NI when they tried to kind of sell TestStand. Normally, in a production environment or a test environment, you have different solutions because you're inheriting legacy stuff, or you have different skill sets in your team. They tend to be totally decoupled, totally different solutions for different applications, or sometimes different solutions for the same application, just because they're physically apart. This can happen. The idea is go there and recollect what are the common requirements, the common solutions that could be achieved in one system. And yes, keep the different things because different products require different solutions, but as minimum as possible. And then bring as much as we can to a test management software. Yeah. Speaking more about what are these modules, what are these common and different solutions, let's say, depending. So instrument configuration measurements. So depending on the type of card you have, you need to do like a very accurate microamps measurement, or just at ampere range, at the rate of data acquisition. This depends on the solution you have. And then different test modules. So how you communicate your product, how you log your results maybe are different. But in the other side, there are common things that's actually well known in the industry of testing that you could actually bring to a common architecture. And then we are using the power of TestStand to have most of this. In the case of this presentation, I'm going to actually go over more on those three topics, because we're talking about the module that's going to cover user interface. That's actually covered in these three topics, as I think. And how we automate. So a little bit, a very brief description of what TestStand is and how we're intending to use just the basics of TestStand. This automated test executive done in TestStand. The idea is TestStand is comprised of a palette of action steps. You can see on the top there different adapters, it's called in TestStand, for different languages: CVI, LabVIEW, C, .NET, even LabVIEW and XG as well. But then you can use these adapters and incorporate our modules in different languages. And the good thing is, in TestStand, you have a concept of a sequence. So the sequence, you drag and drop your steps, and the sequence is going to show the flow of your tests. That everything becomes standardized, like you're going to log per step. You're going to set a pass-fail condition per step, and then stuff gets more standardized. And the good thing is, TestStand allows us to use a lot of modules from, well, all the modules from LabVIEW. We just encapsulate, in our case, as a LLB or a packed library, and then we bring the code to TestStand. The parameters are all exposed, then you can pass parameters in and out for modules. Or if you have like DLLs or .NET calls, you have adapters for those specific type of languages. They're going to do the same thing, expose the parameters, pass parameters in and out. The good thing also that we achieve in TestStand is the commonality of some parameters. So how you capture the error, where the error goes. So there's always a receptacle for error. What's the status of that action step? So was a pass, done, error, skipped. That's always kind of standardized lingo, let's say, TestStand, and much more. You can log more parameters. You can even log requirements. That's going to tie it up with the results. That's always nice to explore the extra properties which are common. Then now, that's the overall TestStand, but how here in EI we did this adaptation, and we turned this test executive that's going to run in each industrial machine to a turnkey solution. And when I speak about a turnkey solution, that's more or less a simple flow chart. What we want, it's literally product in, pass and fail on the screen. So the operators, they don't need to interact much with configuration, set up devices, open ports, nothing, like not even a button to start. It's just like open application, the application shows ready, just load the products. So that actually speed up a lot of the changeover and debugging for the technicians, because the application is supposed to be self-sufficient in launch itself, pass fail, diagnose in any failures, or self-check and report to a database any failures as well. And then this actually, then it starts like our design thinking ideas here. So what should we collect as commonalities? What should we allow to be the differences between the stations, between the machines? And then maybe 4 key requirements, for key ideas to streamline here. So product features will change, so keep this in mind. So TestStand will cover this. It's nice because then you can just change your module, then you're going to change your test sequence. The order of the test is going to be changing. So maybe cycle time needs to be saved, or you want to diagnose different things, you want to stress test. So TestStand will cover this for us as well. So we can just simply drag and drop steps. Logging different parameters. So again, TestStand is going to help us a lot here. It's just an exercise of a check mark. You check what you need to log, what you don't want to log, and then it's going to be in the reports or the database later. And do I need to integrate this machine actually with other automation elements? So in our case, there are on-road PLCs that actually control safety circuits in the machine, basically actuators and safety barriers on the machine. So they need to be a part of the automation of the test. So we need to interface with the system too. And all this should funnel to a easy maintainable and debuggable code. And debuggable, we always call our system. We don't open much source code in the production floor. Actually, we don't open zero source code in the production floor. They just open TestStand if it's needed. And then get a common user interface. All these elements, they're real plug and play. You can plug, remove, and then you can have more maintenance, jog modes. You can have like 2 different user interface, just one, none, just different depending on the machines. So that's what we want to achieve. How we achieve this? So in the end, then the architecture for this project, we decide to use actually that start with a simple TestStand UI. That's shipped with the TestStand examples for LabVIEW, and then we took the simple one. There's actually a strategic one. That's the last item here. It only needs runtime license. That's actually key for us. We don't want to pay extra for running the machines in our production. Maintenance happens once a month, once a week. So we don't need to have like full development on the machines. Only the runtime license. And then other benefits like the full API is exposed to LabVIEW for LabVIEW. Then you can talk to any elements in TestStand in runtime with LabVIEW. We have user access control. Okay, we know who's going to run the machine. You can then control the flow during the production and then find bugs on the fly. That's very nice because it's a problem happening on the specific batch of products. Is it the machine that's faulty, or is it a product, or it is just a particular unit. You can step through, run again, and make sure your tests are doing what they need to do. This is actually tested in LabVIEW. So it's actually just running the sequence, but actually we need another layer for the user interface. TestStand itself has a user interface, but it's just a flow, and it's not so meaningful for operators. So we need to create our own user interface based on legacy, based on the stuff operators and technicians are used to. And even for us, like, it should be common. We decided to create a module that to be plugged to this sequence, or not. If you just don't want to run the user interface, actually it's transparent, the user interface. The idea is to be easy to beginning with. So the team was, as I showed in the beginning, different skills, C#, C++, Python, different skills. We want to merge everyone now to LabVIEW, and this is the basic template that will be easy for reusability. It's very good for one-to-many. So the idea here, it's one sequence or one execution can talk to different elements on a screen or different user interfaces. Easy to handle errors. So by the QMH style, it's just like you can manage errors as a common or per case or per message, depends on the case. And quick to scale. So we have implementations like I'm going to show here with 2 loops that run in parallel, or we have like solutions that run with 5 loops. So it depends on the application. It's very easy to scale. Nice. Then here's a little bit what we found ready to use and what we have modified for this simple UI first. So TestStand, as I said, shipped with an example called simple UI. And then we took that for an example and then started modifying a little bit for our needs. We kept both the same. It is a state machine in the end, simple, straightforward. It logs a lot of ActiveX controls. So this ActiveX actually is driving all the TestStand engine, which start with user login at the very beginning. Then we adapt to incorporate environments. That's a very nice feature for TestStand. You can build up your project as an environment, so it's very easy to decouple old code with the new code just inside an environment. Then we register these ActiveX callbacks, which is the way TestStand works. Then this part here actually is incorporated in the simple UI. By default, we don't launch and execute a sequence by itself. Now we do, just because we don't want operators they don't need to click anything. It's going to load the sequence for us based on an I file. So then here actually is execution. For operators, it's transparent. The execution is just running as a user interface. In case a technician or an engineer needs to go in front of the machine, they can open the actual TestStand screen and see the flow. And then they can put breakpoints, they can watch the variables, they can step through, they can pause different threads. In our case, we're running 5 threads in the TestStand, so we know how it can be very complicated to build an application with multi-thread. A lot of things can go wrong, and then TestStand help us to just create them very easily. For last, then if you want to shut down your application, there's actually more modification I have done just to communicate this QMH side to this simple UI. We tried actually so much to keep them separate still that I'm going to show the strategy. This sequence here, this VI, is running from a subpanel inside our QMH. So you want really keep the project separated. It lessens so much our problems integrating both, because one project manage only TestStand related, the other project manage the any UI specific stuff that we have. So in the end, it's nice to shut down everything properly, close all the references. Then this is all part of this project. The other side, the QMH side, is another project. It is, when I call projects, totally different source code. They just like call each other with references, but they are separate. They're managed separately. This guy actually gives the meaning here. So we have a TestStand sequence here depicted on the left with loads of steps. Steps could be action steps, could be TestStand related themselves, like we have normally rendezvous, stop, wait, or while, for loops, that kind of things. They're all steps. One of these kind of steps, they can be update user interface. Basically, what they're done is they send a message to our QMH through, there's an FGV, by the way, that knows the reference of the queue. So for TestStand is transparent. From user interface UI display is the only owner of its references still. So that's the way we do. And in some case, we can feedback a notifier in case TestStand needs an acknowledge of some of the commands. So this other project here gives the meaning and gives the API to communicate to the user interface now. And then how implement this? So how integrate? So this is TestStand sequence here. The main idea is these VIs, for instance, we call mode tester user interface is the namespace. Project. They can launch, or they can actually send the message to another user interface outside TestStand and update them accordingly. So in this case here, we have two examples: updating a PLC status. There is another module responsible only to get the PLC status, sent to this module, to this step. This step is going to update the screen or update our EUT tracker, that you can see in which station your product is. So that's that's the maximum coupling we have.
Looks like Luis has dropped off, so he'll hopefully rejoin and carry on. He did a little freeze. I'm going to try messaging him and see how he's getting on. Normally quite quick to come back, but might be having some trouble. So,
hi, Chris. I tried to message Ramesh as well. Seems like he's out of reach.
oh really?
Yeah, I try to check in both ways, his WhatsApp as well as
oh okay.
the Valeo chat is still not reachable.
Okay. All right. This has never happened before. Well, let's just say amuse yourself for a couple of minutes. Let's see whether Luis will come back in. And
yeah, you know, the recent global outages. I don't know if that has happened there now.
yeah. Okay. All right. I'll drop him an email or something and go old school, and then I'll check back in a couple of minutes.
Okay.
Speak to you in a sec. Oh, he's back, I think.
Oh, sorry guys.
No worries.
Was my side, I believe, dropped.
Yeah, I think so. Just saw you frozen.
Oh, okay. When I stopped.
Yeah. Probably back.
What was the last words I
yeah,
did?
I don't think it wasn't on this page. Slide.
It was here?
No. If you go back. Yeah, keep going, yeah. I think we were here.
Here?
Yeah, sorry, next page.
Here?
Yeah, this one. I think we've got to the end of that one. Yeah.
Oh.
But maybe just recap that one's probably a good start.
Okay. I have my presenter view in front, so if you could go over. Okay, I can continue from here.
Cool.
So, yeah, what I was saying is, I'll go back just to recap myself. So I was explaining the two different architectures, the two different projects, and then how now we implement them. So how they are used together. So on the left side here, on the left-hand side here, I have a TestStand sequence. These are kind of steps in TestStand. One of these steps, or a few of these steps, they are the user interface. We call multi-tester user interface, particular namespace. And then these guys do update the screen for the user interface when we are ready to. So now is the sequence that dictates the flow. This QMH side here, only listen in this case, and waits to be updated. Then I was just now here showing what actually is the flow of the full architecture, who calls who. So in this case, we still keep a legacy of the operators are used to click a launcher on the screen. And then this launcher actually calls all the applications. So again, the idea of a turnkey solution for the operators. They launch an application, only very minimal interaction, then the machine is ready for a start. So the idea here, this launcher calls a packed library. This packed library have all the LabVIEW code that actually launches the main application, the main UI, the QMH. This QMH, inside of it, is going to call the simple UI. The simple UI, it's going to then here TestStand is taking control of the tester. And then it's only the sequence that's driving the flow. The main user interface is only listening at this point. And the loop is closed here. The sequence dictates the flow, send the messages to the user interface, back and forth, acknowledge if it's needed. And now this guy here is actually the main application. And this guy is loaded in a sub panel. I'm going to show the next slide. So this is here, the QMH application, that high level. Basically, this application, again, it owns its own queue name, and then it controls its notifiers. The simple user interface is launched in the very beginning and delegated to a sub panel. So you want, as I said before, you want to keep the project totally separated so it's easy to maintain. Then this guy just needs to be loaded from a sub panel. And more parameters are fed for this guy. but they're sent to the user interface, sorry, to the TestStand side. It's the name of the sequence, the name of the environment, something nice to separate in TestStand. And then they're fed here. These are the small modifications we have done to the simple UI, but they still mostly the same. Actually, here is inside of the action steps that we use in TestStand side, just more details. What are they? So they're basically enqueuers for this QMH. The reference is kept inside in FGV, but basically I have a control that's going to be turned as a parameter in TestStand, fed to the enqueuer. This enqueuer has just a basic element. It is taking the name of this control or parameter, if you want to talk in TestStand language, and the payload is the content of the control fed to the enqueue. Inside here we have the reference of the queue, so TestStand don't need to liaise with any references. And this is just sending to the user interface. There are mechanisms to receive back, so TestStand can wait for a message back. We use kind of notifiers this way. And this is actually one of the very, I would say, weak or simple solutions. You send a message and wait for a notifier, and then it's prone for errors if you send multiple messages. Who is going to receive the notification? It's a known problem, but we use with cautious. There are other solutions here implemented. I didn't demonstrate. They are more useful for multiple messages, multiple replies. Then this is just a simple one. If TestStand, a single execution is waiting for a single message back and forth. Okay, and then this is actually now inside of the QMH on the other side again. When the message is sent, a case is triggered. So we dequeue a message. It's going to do something. It helps us a lot, so we don't need to liaise with all the complexity of buttons or indicators. The part of the code here is already done. So you just send a single message. All the proper nodes or anything you need to do for particularities of the indicators is done inside this UI. And then in this case, for instance, if I send a fail, my machine is going to indicate a fail or pass in the screen, totally decoupled from TestStand side. These are more screenshots of what we achieved. They supposed to be really gray, really simple user interface. Like few indications of the screen is still not dead, but not much actions on the screen to the distract operators. Remember, our processes are most of the time semi-automatic, so operators still load and unload the products. So they are watching the screen, but basically looking to the pass fail, and if fail, a fail reason. So other details are just there for quality, for technicians to take a look. Okay. Yeah, so I want to show this. I think we have good time. Just to show in action. I have here a simple demonstration that I launch from my project. Just have that launcher I mentioned before. This launcher is merely launching the main user interface from here. It's the only executable. It just launched on a separate screen here for me. So first of all, it opens the login manager. In the case of my developer machine, I don't have another user. So here we can differentiate how operations load. By the way, operations there, we have a very simple user password, and technicians we have a more complex password. That's basically how we manage. And then this main interface is launched. In this case here, all that stuff I explained at the beginning, launching, loading, it has happened already. The application is running in the background here. This interface will be updated when it's ready. Just, yep. So I can see my screen, my counter here, my cycle time clocker here, just counting and updating the screen after a certain time. I have just a simple demonstration. It's a random number generator and a comparison for that number. Just demonstrates. It's actually the operator screen. So the user interface is this application, but the simple user interface is launched from another. We chose to use tabs, but inside this tab, there's a sub panel. And the sub panel actually is the other VI that actually don't belong to the main application. And then that's nice because if we choose to have the control of the flow or take a look what's going on, I can start enabling break if failure, break on breakpoints, and then enable or disable breakpoints, step over if I want, and keep watching what happens on the screen or watch what happens for the variables. I particularly love this because I can change the flow of my application in runtime. This is purely runtime. If I release here, so I don't want to break on failure, I continue everything. I can have multiple threads, by the way. It's totally the runtime environment. With a simple runtime license that actually TestStand always is the way it works. So there's always a runtime license implied, but we still have a minimum maintainability. I believe you could put much more. We just stopped it here. In this case, I did a very bad TestStand solution, a infinite while loop. I never do this, by the way. This is just for the sake of demonstration. But after all the executions to complete, you would have a report. In our case, it does every report, and we can see the video reports in here. All the time I break my application, I can play with variables if I want, and then change the values, change anything I want, and start debugging. That's so important. That's why it's important to log in. In this case, I logged as an administrator. I have full control, but an operator doesn't not even stop the application or pause. Even this part of here is all disabled for them. Then in this case, I can easily debug things and try to understand what's happening with my code, or with a particular batch of production, or if the tester has some sensor broken. Yeah, that actually brings myself to a conclusion, guys. I would actually leave this running here, but I would like to thank you. It was simple, but I'm open for questions if you guys have any.
Nice one, Luis. Anyone got any questions?
Narayan here again. Thanks, Luis, for your presentation. The thing with TestStand I generally struggle with is convincing the management team to showcase the cost benefit of TestStand compared to developing our own test executive application in LabVIEW. So how were you able to convince the management to go with TestStand? This is the question.
Yeah, that's really every single colleague. Thanks for the question, Narayan. Every single colleague, they have the same. When they start, you TestStand. My manager actually is on the call, so he have listened a lot in the beginning. And thanks for him as well. So they trust in the idea. So yes, it's actually expensive to start with. So the idea of you pay license for every single machine you have on the floor, it's hard to sell at the beginning. But the reusability, it's getting us keeping going, because any change you need to do, as I showed, you can change almost on the fly. It's not a good practice to change on the production floor, but actually you know that it happens when you're in production in a rush. You can change there, fix something very quick, and then go to your bench, reproduce, and then make sure everything's fine, commit to your repository, make sure everything's fine. But it's easy to scale, easy to maintain after when you have some control on the tool. That's why I like it. But yes, the investment in the beginning, it scares a little bit. But the nice thing is you need just one or two developer license. Then you buy license per machine. They're not that expensive, but that's it. You don't need to pay anything after that, and you just collect benefits. In our particular usage, we use the VLA. We have a VLM, so we have a network license. So I can log that machine with my account and then use a developer environment on that machine if I want to modify the code. So it helps a lot if I want to debug on production. So all this infrastructure, I think it's going to pay off one day. And now we are seeing like a rollout of machines, reusing the user interface, reusing most of the modules developed, and very little modifications to be done for new machines. And that, in my perception, is starting to pay. It's going to start pay off. In my case here, after 9 months of the development, then they start paying off because the development of the sequential machines are much lower.
All right.
I hope it answers your question.
Thank you. Yeah.
Yeah, Nathan just added to that by saying that he's kind of sold it by the fact that it's quite an easy environment for people that are using like MATLAB and Python to also integrate with. So it's not it's LabVIEW compatible, but it's also compatible with other languages as well, which is quite a good point.
I think Narayanan, he asked something else. There is a formal cost-benefit presentation from NI. I can find the URL and send. I don't have it now here.
All right. Okay. Thank you.
It helped me at the beginning. Yeah.
So, Lewis, have you got some comparable experience of doing a test executor, test executive, sorry, in LabVIEW that you can kind of relate to and really advocate not doing that? Obviously, there's scenarios where TestStand isn't applicable, but it'd be good to hear that sort of comparable experience, I guess.
We start calling like complex machines. In this case, here is a multi-tester solution. There are 5 threads running parallel. I think it justifies it just because this machine also has PX size and it costs a little bit more expensive. But single station solutions, we are doing still in LabVIEW, full in LabVIEW. We don't deploy TestStand for small stations. It's just because of the amount of developers with experience with TestStand, I believe now.
Yeah.
But maybe it would be an overkill. We don't need to report for every single execution. You don't need to track a lot the database. So we have developed our own small applications for that. But actually, I would love to. If everything would be TestStand, more stuff would be standardized. So that actually, it's just because I didn't try.
Yeah. Yeah.
I still didn't stumble on something I wouldn't use, but I can't use now. That's my impression.
Yeah. Nice. Has anyone else got any other questions? Nathan, you put a comment in the chat there.
Sorry, I should elaborate. So that was in regards to the smaller test benches. It's actually something we're doing in one of our current projects. So what we're actually doing is we took over the execution model. So to remove stuff like reporting and stuff and other things we didn't need. So we can really tailor make it. So they were complaining about the reporting coming out of it, so we disabled it, and then, for example, put in a Diadem plugin to make our reports in Diadem. To give you an idea, so it does scale to smaller applications when you start messing around with that engine.
Yeah, you can build stuff from scratch from the engine. You can have full control of TestStand, not even using any of the user interface that comes with TestStand, driving your full tests through the APIs. Yes.
Is there anyone on the chat that's not using TestStand that's convinced to use TestStand? Or they disagree? Okay. So Simon, you're going full LabVIEW with your test executable, executive. Keep getting that all mixed up.
Yeah, I would go with TestStand any day. It's just that I need a convincing answer for my management.
Okay.
That's the thing.
Yeah, yeah.
Yeah, talk
So-
to your local NI representative. They gave me loads of good documentation. They have this kind of showcase and actually the return of investment and how we should plan and when is applicable, when is not applicable. There's a nice showcase. I just can't find the link now.
Right, yeah, that would be useful. Yeah.
The website. NI.
So Simon, you're actually going the opposite, the other way completely, in terms of NI kit as well as the software. So it's Raspberry Pi and Node-RED. Yeah, I get your comment there actually about TestStand is great, but over the top for what you need. Yeah, so it's got to be applicable to the kind of application that you're applying it to, right?
Makes sense. Yeah. In our case, like it's always, yeah. In our case, like it's more, we still call time to market, so but it's time to deploy the machines under production. We need to be able to copy and paste, literally, stuff already developed. So TestStand helps a lot. It's literally copy and paste steps in there. It helps a lot to reproduce and scale our production. That's the goal.
Yeah.
Going forward.
Awesome. Any other questions or comments, guys, before we wrap up? Unfortunately, we're going to be finishing a little early today, just because we lost a presenter. So unless anyone's got anything they'd like to, on the fly, have chat about, then we can obviously do that. But if not, then we'll wrap things up early.
I'm just pasting here the link. If Narayan was asking, I think this is actually a how to build a test system, and then one of the items is total cost of ownership. I think that's very interesting to sell to high managers and directors. They really explain how the cost of development drops over time when you have like a solid foundation of test solution and reusability is in
Thank
place.
you. Thank you for that. I shall go through the details, Louis.
Yeah, there are loads of nice links there.